Welcome to Science Boosters. In this video, we will be exploring one of the most fascinating theories in all of science related to the origins of the universe, which is the Big Bang Theory. For decades now, the Big Bang Theory has remained the cornerstone of our understanding of the origin of the universe. It's a theory which has been very widely accepted throughout the scientific community of cosmologists. So, let's explore what does this theory has to offer to our understanding of the cosmos. In the modern science, the conceptualization of the Big Bang Theory originally comes from the works of a Belgian physicist and priest known as Georges Lemaitre in the 1920s. Lemaitre's development of the Big Bang Theory was influenced by his studies in both physics and astronomy. He was particularly interested in Albert Einstein's general theory of relativity, which describes the behavior of gravity and the structure of the universe on a large scale. Lemaitre recognized that Einstein's equations allowed for a dynamic universe, one that could expand or contract. Building on this idea, he proposed that the universe was initially in a highly compressed and dense state. Lemaitre referred to this state as the primeval atom or the cosmic egg. Lemaitre's motivation for proposing the Big Bang Theory stemmed from his desire to reconcile scientific knowledge with the concept of a creation event mentioned in religious texts. However, it was the American astronomer Edwin Hubble's observations in the 1920s and 1930s that provided strong evidence for an expanding universe. Hubble's observations of galaxies moving away from each other and the relationship between their distances and redshifts played a crucial role in supporting the idea of a Big Bang. Over time, observational evidence, such as Hubble's observations of galaxies moving away from each other, supported Lemaitre's ideas, leading to the widespread acceptance of the Big Bang Theory as the prevailing scientific explanation for the origin of the universe. Since then, numerous scientists and researchers from various fields have contributed to refining and developing the Big Bang Theory, incorporating additional evidence and observations. It has become the prevailing scientific explanation for the origin and evolution of the universe. So, what does the Big Bang Theory really says? To put it simply, it says that all that we know of in the observable universe, which is billions of galaxies and trillions of stars, all the matter, dark matter and dark energy, and all the cosmic bodies which we know of and do not know of in the universe, a universe which is spread over a space-time fabric of 93 billion light-years in our observation and understanding. All of this was packed into a single point or single atom. Yes, an infinitely hot and dense single point referred to as singularity, or primeval atom or the cosmic egg. Just imagine the entirety of the universe, compressed into an incredibly tiny, hot, and dense point known as a singularity. It's mind-boggling, isn't it? So, how far back in time it was? According to the other studies that we will be discussing ahead in this video, this was the state of the universe 13.8 billion years ago, when the entire universe existed as a single atom or singularity. But then, an extraordinary event occurred, a cosmic inflation, or simply, the Big Bang. In an infinitesimally brief moment, this singularity underwent a rapid expansion, causing the universe to expand and cool down significantly. As the universe expanded, matter and energy began to form, setting the stage for the cosmic spectacle which unfolded into billions of galaxies and trillions of stars and planets, and every other phenomenon, such as black holes, supernovae, nebulas and so on that we observe today. Now let's discuss some of the aspects of the Big Bang, the supporting theories which have upheld the validity of the Big Bang Theory till now. Theories that have allowed the Big Bang Theory to remain our go-to scientific theory for explanations regarding the origins and the evolution of the universe. Number 1. Cosmic microwave background radiation. Imagine going back in time to around 380,000 years after the initial cosmic explosion. At this point, the universe had cooled enough for atoms to form, allowing light to travel freely. The light from that era, known as the cosmic microwave background radiation, CMBR, fills the entire universe. Detecting this faint radiation has been instrumental in confirming the Big Bang theory. It provides strong evidence supporting the idea that the universe was once in an incredibly hot and dense state. Number 2. Expansion of the universe. One of the most groundbreaking discoveries supporting the Big Bang theory is the observation that our universe is expanding, and that too at an accelerating rate. Imagine a loaf of raisin bread baking in an oven. As the bread rises, the raisins move away from each other. Similarly, as the universe expanded, galaxies and other celestial objects moved farther apart. This expansion can be traced back to the initial singularity. Number 3. Formation of elements. The early universe was primarily composed of hydrogen and helium, the simplest elements. However, as the universe continued to cool and expand, gravity played a crucial role. Gravity caused the gas clouds to condense, leading to the formation of stars and galaxies. Within the fiery cores of stars, elements heavier than hydrogen and helium, such as carbon, oxygen, and iron, were forged through nuclear fusion. These elements would eventually seed future generations of stars, planets, and eventually, life itself. Number 4. Hubble's law. Edwin Hubble, an American astronomer, observed that galaxies are not only moving away from us but also from each other. He discovered the relationship between a galaxy's distance from us and its velocity. Hubble's law states that the farther a galaxy is from us, the faster it appears to be moving away. This observation strongly supports the idea that the universe is expanding uniformly in all directions. These are just a few early theories, which have supported the validity of the Big Bang theory. Keep watching the Part 2 of The Big Bang Explained, for further explanation and to know about more of the supporting theories and the limitations of Big Bang. Let us know your thoughts in the comments section. See you in the Part 2. Thanks for watching. Like and subscribe as there is lot more to come.